Hello and welcome to another video tutorial by Easy Academy. So in this video, we are taking a look at the second part of the video series on running Apache Kafka, the vanilla Apache Kafka on Kubernetes. Now this Kubernetes server will be running locally on my laptop, but in a subsequent video, I'm going to cover how to do that on Azure Kubernetes Service. So running Kafka is something that can be challenging sometimes, and if you're not familiar with how this is done, you can spend a lot of time just trying to get Apache Kafka running. But like I did in the first video, this particular one would be very easy once you have your Kubernetes cluster set up locally. So let's get started with what we want to do. The main objective here is to get you started right away. So that's what we're going to focus on doing, where you can deploy your cluster in just a few minutes. So for this particular video, I'll walk you through how to set up your Apache Kafka environment on your local Kubernetes cluster, which could be on Minikube or Kind. Now, in the next video that I'm going to be working on next, this is going to be showing us how we deploy this on Azure Kubernetes Service, a cloud service provided by Microsoft Azure. And then once we are done with setting up the Kafka cluster, we're going to exploit like we did in the first video. So if you have not watched the first video yet, please take a look at it. The link to that video will be in the description of this particular video. So let's get started. But before we do that, if you have not subscribed to the channel, please feel free to do so right now. So subscribing to the channel will allow you to get instant notification of new content that comes up as soon as they are published. Also, if you like this particular video, please feel free to give it a thumbs up so that more of this content can be created in the future if we have a lot of people that like it. I also have other social media accounts like Twitter and GitHub, and also you can check out my website for content that I have on related topics. Now, I have a course that walks you through how you can leverage open source software to process a lot of data. So all the technologies and techniques on how you can aggregate data, how you can store data, and how you can process data using open source software is covered in that course. And of course, Apache Kafka is one of those topics and features of the course. So take a look at it and give me feedback if you are interested, and I would really appreciate that. So getting started with today's content, like I covered in the first video, you have to take a look at this GitHub repository, and then you can follow along with me as I walk through these steps. So in the previous video, we covered how to deploy it on Docker Compose, but in this particular one, I'm running a local Kubernetes cluster on my laptop, and I'm going to be using that to deploy the Kafka cluster. So that's our focus right now in this video, and in the subsequent video, we're going to be doing exactly the same thing. However, the Kubernetes cluster is going to be running on Microsoft Azure, and there are some slight differences between running it on a Kubernetes cluster locally and running it in the cloud. One of those differences is that the local version does not have persistent volume, and also it does not use a load balancer to route the services. So those are the two main differences. And if you take a look at the manifest of the local version on my desktop as well as the one in the cloud, those are the two major differences. So just persistent volume usage and also using the Azure load balancer. So that's the difference, but all the syntax should be pretty much the same. How it is deployed and how it is explored is going to be the same thing. So once we are done, of course, we're going to explore the cluster. But before that, let's get started with how we set it up in our local environment. So I'm going to switch now and go to the URL. So if you head out to this URL, all the steps that you need is available in this outline. The ones we're going to focus on is how we're doing it locally in our desktop. So if you have not set up your local environment yet, you can head out to this page, and this page shows you how you can grab either Kubernetes from Docker Desktop, Minikube, and Kind. And once that is set up, we'll set up the kube control client and then install Helm. And once Helm is installed, kube control is installed, our cluster is up and running, we are good to go, and we can get started right away. So heading back to this one, we're going to be running this locally. So to do this, I would have to clone the repository to my local environment. So I have already done that, and I have my Kafka in a box directory, as you can see here on my screen. So if you need to zoom in, I can do that, so you can see all the different files. So this is what we have right now. We have our Kubernetes folder. So we log into we navigate into that folder, and if you get in there, you're going to see the Helm charts folder. This folder has two sets of Helm charts. The first one is the one for the Azure cloud, which will be used in the subsequent video, and this particular one is is the one for the desktop version. So that's the one we're going to focus on. All right, now in terms of the steps, all we have to do is navigate to the Helm charts folder, which we're currently in that folder at the moment, and then we need to create the namespace. So if you're not familiar with Kubernetes creates compartments called namespaces, where you can segment different resources and different applications based on the namespace. So a namespace is kind of like a partition that we use to aggregate or collect different resources and group them together. If you're interested in learning more about this particular concept, please put it as a comment in the description, and I would create something that demonstrates the different features of Kubernetes and walk you through that. So now I'm just going to create the namespace, and that's a command. So I gave you the command here. You head out to your terminal and you run kubectl create namespace river. So this allows Kubernetes, or instructs Kubernetes, to create a namespace called river. So that is a command, kubectl, so people call it kubectl, create namespace called river. So we do that. Oh, the namespace already exists. So if it already exists, then that means that I may have created it already in the past. So now I can take a look at, I can run the kubectl, specify the river namespace, get ports. All right, so nothing has been deployed yet in this particular namespace. So that is good. All right. Next, once the namespace has been created, I'm going to be deploying Kubernetes in legacy mode, which means with Zookeeper. So to do that, I will follow these steps over here. So the first thing will be for me to create the Zookeeper node, let that be in running state. And once it is in running state, I can now create my brokers in legacy mode. That depends on that Zookeeper. Then of course, I log in to the broker, and then I can start my exploration. Pretty simple, right? So let's get started with creating the Zookeeper instance. So I use Helm. I specify that I want to do an upgrade or installation. So doing the installation this way allows me to be idempotent, meaning that I can run the same command again. If it has not been installed before, it will be installed. And then if it's already installed, then it will update or upgrade the existing installation. So this is better than doing an install which assumes that nothing has been created already, and it can give errors if that particular release has already been created. So this particular command here allows me to simply upgrade or install, and it is idempotent. Idempotent means that you can try the same command again and it will not give you errors because you are doing a retry or you're trying it multiple times. So now we're going to run this particular command. So Helm upgrade install Zookeeper, and then we have that executed. So it does not exist and it goes ahead to install it. That's great. And this is the first revision. So now what I'm going to do is I'm going to retrieve ports. So ports are how containers are deployed on Kubernetes. A pod may contain just one container or multiple containers, but doing this allows me to list all the pods that are running in this particular namespace. So kubectl -n or -n specify the namespace river, get pods would list all the different things that are running here. So once we have that, I would like to take a look at the logs for this particular pod to see what is going on. So it looks like everything is up and running. So Zookeeper is up and running. It's been about 59 seconds right now, and I think it's ready to go. So once that is done, the next step now will be for me to deploy my brokers. And to do this, I simply run one single command, helm upgrade install. I specify the release, and then I specify where my charts are located, and then I specify the flag that says that I want to enable the installation in legacy mode. So doing that, of course, installs it. So now if I do helm list, I can see that I have the Zookeeper and the River broker release already installed. So now let's take a look at some of the ports that are available. So my Zookeeper is already ready to go, and the brokers are now loading. So once the brokers are fully loaded, which they are now, it took about 28 seconds to do that, I can now go ahead to explore the cluster and see what's going on. So we're going to explore the cluster in legacy mode, and of course I have to first log into the cluster so that I can exploit it correctly. So to do that, I would do the kube control, specify the namespace, do exec deploy, and then specify the name of that particular deployment, which is broker2, and then invoke the batch command. So doing that allows me to do this. So now I am inside the particular container, and I can head out to the bin folder. So we are inside the bin folder, and now we're ready to explore. So all I'm going to do here is going to be to do a list of all the different topics that we have available. We should not have any topic in this particular cluster because nothing should have been created yet. So this should return an empty list, and once that is done, I will create a few topics, and we can take a look at the topics and describe it. So let's go ahead and do that. So I'm going to create a topic with only one partition and one replication factor. Okay, so while that is doing, let me get another one ready. Then I'm going to create another one with two partitions and one replica. All right, so this one has two partitions and one replica, meaning only one copy, and it is split into two separate segments or partitions. That one is done, and then the last one is going to be three partitions with a replication factor. Let's do 3. So let's do 3 as a replication factor. So we have created that. Now while that is in progress, I'm going to attempt something that should not be allowed. So in this particular example, I'm going to try to create a topic with let's say 5 partitions. 5 partitions, but a replication factor of 3 US capitals. So create 5 partitions with a replication factor of 5, meaning that I want to have 5 copies of this topic data anytime we have a particular record or partition that has been created. This should not be allowed because in Kafka, the number of replicas cannot exceed the number of brokers available in the cluster. So this should not be allowed. And if I attempt to do this, we're gonna get an error saying that we have exceeded the number of available brokers because we have tried to specify the number of replicas that have been that are greater than how many brokers we have available in the cluster. So this should fail with that error. And one of the reasons why I am setting up this particular environment is so that you can see how Kafka works in production and works in real life. Some of the tutorials that are out there are only allowing you to see a single broker and all those things, and that's not really realistic. So replication factor is 5, and this should not work because it exceeds the number of available brokers, which is 3. If we reduce that to 3, that should work. So in this case, I can only have 1, 2, or 3, and not anything more than 3. So doing it with 3 should actually work, and we should see that happen right away. So that is what is going to happen in a few seconds. So topic has been created. Now if I go back and do a list, I should see all these topics that have been created. So I'm actually going to go ahead and describe the US capitals, and let's see what is happening with that particular topic. So describing it should tell me all the different replicas that are available, where the partitions are being hosted, and which broker ID is responsible. So here we see the US capitals topic. So the US capitals topic is this one right here. So we have partition 0 is being hosted, or is the leader for that partition is broker number 3, and these are the copies that are available, and all of them are in sync. And then we have another topic here, city population. It has only one partition. The leader is on the first broker. And then we have world capitals that has 3 partitions, and these are the leaders for each partition. These are the replicas for that particular partition, and then this is the in-sync replica. So in-sync replica simply means that all the different followers of that particular topic that are following the leader are in sync. If it is not in sync, then that will be less than the number of replicas that we have. And then for country population, we have partition 0. The leader is on the first broker. The replica is on the first broker, and then we have in-sync replica as 1, and so on. So that is all the different things that we have for this one, and this concludes this demonstration. So as you can see, we were able to run Apache Kafka on a Kubernetes cluster that is running locally, and everything took about, I would say, 1 minute or 1.5 minutes to get deployed. So doing this allows you to just focus on deploying the cluster right away and getting to learn what you need to learn on Apache Kafka, without having to be an expert on how it is set up, and that could waste time and get you frustrated. So in the next video, I am going to focus on how we deploy this on Azure Cloud, and I will also highlight some of the key differences that I mentioned earlier. So if you like this particular content, please feel free to click the like button or give it a thumbs up, and that would allow me to know that people like this content. If you have any questions, please go ahead and put that in the comment section, or if there's something about this particular video you would like me to elaborate further on, you can go ahead and put that in the comments, and I would take a look at that, and that will give me feedback when I'm working on new content. Like always, you can follow me on Twitter, GitHub, and you can check out my website. And if you like what I'm doing in this particular video, and you would like to learn more about how to use open source software to process data, to store data, and to aggregate data, you can take a look at my course on Udemy, where the link will be in the description area. So I thank you very much for your time. Please feel free to share this video with someone you think would benefit from it, and I will see you in the subsequent videos. Thank you very much for your time.